Pues voy a presentar oficialmente al siguiente ponente para no demorar demasiado el timing de la jornada. Es un placer para mí presentar al profesor Antoine Bechara. Él fue uno de mis maestros, uno de mis mentores también. Es decir, no solo me enseñó muchas cosas, sino también me ayudó en muchas otras cosas. Fui a verle a Iowa por el año 2004 y fue mi primera exposición a un laboratorio de referencia internacional y fue una experiencia inolvidable, la verdad. Era un laboratorio donde había muchísimos investigadores que trabajaban de una manera increíblemente coordinada para resolver preguntas muy importantes. Fueron el laboratorio que consiguió poner en el mapa la emoción en el contexto de la toma de decisiones. Fue el laboratorio que generó la teoría del marcador somático, que muchos de nosotros usamos tanto en investigaciones como para explicar nuestras decisiones de la vida cotidiana, que es todavía más importante. Sigue siendo una referencia mundial con no sé cuántos cientos de publicaciones, algunas de ellas en las mejores revistas científicas, incluyendo Science y Nature Neuroscience. So, Antoine, it's my pleasure to introduce you today. A couple of good things about you, because you've been in Spain a couple of times, you probably understand half of it by now. And so he's going to be speaking about a 3-system neural model of addiction and therapeutic strategies for correcting impaired decision making. Por favor, un aplauso de bienvenida al profesor Antoine Bechara.
Thank you very much, and I am very happy to be here again. All right, so this morning we heard very nice talks about cocaine addiction, and these are hard drugs addiction. And as we remember, a lot of them talked about potential impairments in this part of the brain, the prefrontal cortex. And this is really a system, we call it the reflective system. And what I want to try to explain now, that not all addictions are really associated with impairments in the prefrontal cortex. The majority of our addictions involve abnormalities in those other systems that I will explain the model in a few minutes. Because when we talk about addiction, nowadays, everything, we call it an addiction. If you smoke, well, you're addicted to smoking. If you gamble, you're addicted to gambling. If you play the internet, if you check Facebook a lot, you're called addicted to the internet. Imagine if every single one of those of addiction is associated with prefrontal cortex impairment. I hate to say that, well, maybe all of us then have impaired prefrontal cortex. That doesn't make sense. In the majority of these cases, the addiction is what I call domain specific. That is, it's specific to one thing. Somebody who's addicted to the internet only loses their decision-making capacity only when it comes to the internet. They cannot resist it. They cannot stop using it. But they're functional in every other aspect of their life. So they make good decisions when they work at the bank or when they work at school, which is different than the type of addictions we heard about this morning. When you're really addicted to heroin or to cocaine, then there is strong implications of the prefrontal cortex. And when this part of the brain is impaired, then there is decision-making impairment all across the board. So it's non-domain specific. In those cases, the individuals, they make poor decisions in almost every aspect of life. They can't hold a job. They probably go into financial ruins. Their family is broken up. So this is what I'm going to try to talk about. I'm going to try to find or show you some of the empirical evidence that a lot or the majority of addictions usually involve abnormalities in other neural systems. Only few, and especially those that relate to hard drugs, involve abnormalities in the prefrontal cortex. And at least we described in our theoretical framework, we described at least 3 neural systems that are implicated in addiction. One of them is the old system of the mesolimbic dopamine system, dopamine, striatum, and some people add the amygdala to it, and we call that system the impulsive system. So by and large, it's a subcortical system, and this is really a system that drives the individual towards reward or towards the drug. So it's sort of like the accelerator of a car. And then we have the reflective system, and that's the prefrontal cortex system. This is the system that allows us to put a stop to any behavior, any decision that could lead to negative consequences. So this is the system that allows us to self-control and not to go down spiral that lead to severe addictions and ruining our life. So in other words, even if we experiment with drugs, but we try to put a stop to it at some point. And more recently, we discovered a third system, and that's the insular cortex system. And we discovered it in the context of people who smoke. So they're heavy smokers, and then they get a stroke. And after the stroke, all of a sudden they quit smoking, and they never touch the cigarette again. And when we look at the brain regions that are affected by this stroke, and we find that it was the insula that is really common to all those cases of stroke that really led to a disruption of smoking addiction. And we theorized afterwards that the insula really plays a role in basically sensing signals that happen in the body. For example, when you're deprived of smoking, when you're in a withdrawal state, or even when you are in other mental states like depression or anxiety. A lot of these states, they have manifestations of changes in the physiology of the body. So the insula is in a position to sense these changes in the body, just like the somatosensory cortex senses whatever we do in the skin and in the somatosensory system. The insular cortex, it's the anatomical region that receives all the internal visceral sensory systems and also the gustatory systems. So the insula is in a position to sense what happens inside the visceral body. So once the insula sense that, we assume or we believe, there are a lot of evidence or there are a lot of theories on that this interoceptive signaling lead to a subjective feeling of craving or urge. So probably the insula is one of the main neural structures that lead to the experience of a subjective feeling. We're not saying that the subjective feeling happens in the insula. The insula is a key neural substrate that lead to that subjective experience. So there is a subjective experience of craving or an urge, and that experience has consequences, has behavioral consequences on the taking of a drug. So on one hand, it exacerbates the activity of that habit or impulsive system. So the person becomes even more impulsive, and at the same time, it disables or it hijacks the activity of the reflective system. That is, even if you try to stop that impulse, even if you try to stop that cigarette, in that particular moment, the insula is playing against you. So it disables the prefrontal cortex, and as a result, that's why the person becomes unable to resist smoking the cigarette or playing the internet or whatever behavioral addiction that they are addicted to. So this is exactly the same thing that I was saying, except it's a more diagrammatic. So I'm just going to explain the model, and then we'll go a little bit to more empirical studies. So this is then the old system, the impulsive system. It includes the mesolimbic dopamine system. This is the system that we studied for decades as being important for reward. And the amygdala, it's probably part of that system. It really it transforms cue or drug-related cues. It links it to that mesolimbic dopamine system. There is the ventromedial prefrontal cortex system, and in this dual model, the idea, as I explained, is that the ventromedial prefrontal cortex tries to control, tries to put a stop on our impulses to seek things that may be rewarding in the short term, but they maybe have long-term negative consequences. And this is the insula system. That's the third part of the neural system. The insula, as I said, is anatomically and physiologically in a position to receive interoceptive signal from the internal milieu of the body, from the visceral organs and from the gustatory systems. Once the insula is engaged, then there is a potential subjective experience of a craving or an urge, and that effect has consequences in that it exacerbates activity of the impulsive or the mesolimbic dopamine system, but at the same time, it disables or it weakens the activity of the prefrontal systems, so the prefrontal cortex is no longer able to resist the temptation to seek a drug or to seek a rewarding substance. All right. Now, most studies, if not all, they show that addictive substances alter the reactivity of the dopamine reward system. And as I said, this is the one that we call impulsive system. And these are really those subcortical structures that you see them over here. And one example is cannabis, marijuana, for example. And this is also well known, especially from animal studies, to exert effects on this dopamine reward systems. And for that, these effects have been interpreted as cannabis being a gateway drug. That is, you start with marijuana, but then you move on to heroin, you move on to cocaine, and so on. But if you look around, and that's what most studies tend to show, that most people who even use marijuana or even alcohol or many other drugs that are known to alter the dopamine system do not necessarily go on to use other harder substances like heroin and cocaine. So you may find marijuana people may smoke cigarette, may drink alcohol, but you may not find them going on and shooting heroin or using cocaine. So there is a point where they stop. Of course, there's a small percentage of those, and usually they're about 5%. It could be a little bit more, it could be less. These are people who are vulnerable or predisposed to go into harder substances, but just very small percentage. Now, most important that the addiction in these cases and that poor self-control to resist the use of that substance seems to be domain-specific, as I mentioned earlier. Somebody who uses marijuana or maybe cigarette, their decision-making impairment is only in relation to those substances. They don't have decision-making impairments in other domains. For example, they probably keep doing their job very well. They hold a job, they're successful at what they do, so they don't have an impaired prefrontal cortex all across the board, and that's why most of the time they remain functional in their daily life. Now, there are many examples of addictions similar to marijuana, where the dopamine reward system is involved, but the poor self-control in decision-making to stop that addiction remains specific for that particular substance. And we all know that smoking addiction is one of them. Most smokers, they just smoke. They don't necessarily shoot heroines. Alcohol is another example. All of us drink alcohol. Gambling addiction. Nowadays we have internet addictions. And these, people describe them as true addictions because really you get withdrawal symptoms when you stop doing them. You start having really stereotypical impulsive behaviors when you get around the stimuli or the cues of those things. But they are specific to those cues. So they don't go. Somebody who's addicted to the internet doesn't necessarily go on and start using cocaine and heroin. So there are domain specific. And then people call almost everything else addiction. You hear about your friends calling you're addicted to coffee because you drink too much coffee. Chocolate addiction, they call people you're addicted to chocolate. So there are a lot of addictions, but these, I want to make sure that those kind of addictions, believe it or not, they do alter this dopamine reward system, but I doubt that they are associated with impairments in the prefrontal cortex. So most of the abnormalities are subcortical. In most of these people who are addicted to these substances, I would say they still have a healthy, normal prefrontal cortex. Now, in contrast, and this is what we heard this morning, when addiction to hard substances like opioids or illicit drugs like cocaine is encountered, then we observe poor decision-making that is non-domain specific. And it includes poor decisions across many facets of life, and which basically end up leading to financial ruins. Probably the person loses their job. They probably get in troubles with the law. So there are a lot of problems that are associated with those kind of addictions. But the percentage of the population who really succumb to those kind of addictions, it's not very high. It's probably about 5%, but somebody may get some studies and have exact statistics. It may be higher in some instances, it may be a little bit lower, because it could go probably as high as 10%. But, it's about 5% of the people. These are the ones that end up addicted to those hard substances. Now, although a majority of people who use alcohol and marijuana maintain a functional life, and their poor decision-making remains domain-specific, there is a small percentage of them, too. I mean, there's a small percentage of alcoholics, small percentage of people who use marijuana also end up losing self-control and across the board, and then their impaired decision-making becomes non-domain specific, similar to the ones who use hard drugs like opioids and cocaine. But overall, this is a relatively smaller sector of the population, and the problem is likely related to impairments in what we call the reflective system, or this is the system that includes the prefrontal cortex. And the question is, why some addictions remain domain-specific and the affected individual remains functional for the most part, but why some addictions become non-domain specific and the affected individual becomes dysfunctional and a poor decision maker across many aspects of life. Now, the hypothesis is that addictions, such as those involving marijuana, nicotine, alcohol, or activities like gambling or internet addiction, are characterized by low-risk perception. That is, they are rewarding activity, they engage the dopamine system, but people perceive them as not very high risk. You know, it doesn't get you in trouble, it doesn't take you to jail, it doesn't make you lose your job. I mean, it's like drinking coffee. I mean, coffee pharmacologically, it activates the same dopamine system that is activated by cocaine. If people drink coffee, no one sees coffee as something that is very harmful. So people engage in those rewarding activity. So the person does not perceive that too much risk is involved when someone decides to take them. And here I'm going to take probably a little bit of a radical position, because while we talk about heroin addiction, which is illegal and which is dangerous to take, probably people who become addicted to opioids as prescription medication, because they're taking them from a doctor. They see them as safe. You know, they're medically approved. Probably a lot of these people end up, although a very small percentage, they go on to shooting heroines and using other drugs. But probably a majority of them stay in that domain-specific impaired decision-making. That is, they just use these opioids just to function. And then they do their job, you know, they're okay, they don't go on stealing banks or cheating people. They remain functional for the most part. In contrast, addictions that involve illegal substances and hard drugs, then they are characterized by high-risk perception, because accessing these drugs, first of all, it involves breaking the law in dealing with unscrupulous people. So people know that they are taking too much risk when they decide to use them, and they may continue using them despite encountering negative consequences. So the fundamental brain difference then between those addicts and the other ones is that in addictions involving decisions to use a substance, despite a very high risk perception of that substance use, then there is a dysfunctional prefrontal cortex. And these are mostly the addictions that we were talking about this morning. And the question is, where does this dysfunction comes from? There is a debate. People think it's because you use the drugs, that's what causes the neurotoxicity in the prefrontal cortex. I like to argue the opposite. I like to say that this dysfunction actually precedes the addiction. That is, people are born with somewhat impaired prefrontal cortex, and that impairment, that's what predisposed them to becoming addicted to hard substances and to have poor decision-making all across the board. I will mention again, where does this dysfunction come from? And there are at least two possibilities. One of them is genetic, and the other one is environmental. That is, during early life. And I will mention a little bit about that later on. In contrast, addictions involving decisions to use a substance which is perceived as a low-risk substance, then there is no clear evidence for a dysfunctional prefrontal cortex. And you know, if you want to look at coffee addiction or chocolate addiction, I would be surprised if you see abnormalities in the prefrontal cortex in those individuals. So the brain abnormalities appear either at the level of the mesolimbic dopamine system or the insular cortex. So really at those subcortical regions and not at the prefrontal cortex lesions. Now this is some very quick review of some of the empirical evidence in support of what I've been saying. Now, we know that substances that are really high risk, like heroin and cocaine, and like what we heard today, they do have hypoactive reflective system or a dysfunctional prefrontal cortex. And of course, there are many, many, many studies that documented this impairment, but we did some of that ourselves. That was in the late 1990s, early 2000s, when we were studying patients with frontal lobe lesions. This is really a picture of Phineas Gage. And at that time, we developed what is now known as the Iowa gambling task, really to detect and measure the decision-making impairments of patients like Phineas Gage who have damage in the prefrontal cortex. So we tried to compare the profiles of the patients who have frontal lobe lesions with the profiles of drug addicts who use, they are polysubstance abusers basically. They use heroin, they use cocaine, they use alcohol, they use everything. And we see at least in a subgroup of those addicts, there is a subgroup that match patients who have frontal lobe lesions. So there is a strong evidence of impairments or damage to the prefrontal cortex. Now this is a significant percentage. It's about 23% of the sample. But remember, all of these patients are drug addicts, and they are in treatment, they are in clinics. We find, good percentage of them, they are similar to patients with prefrontal cortex damage. But there's still some of them who look very normal because they don't show any impairments. So that even among the patients who use hard drugs, and I would say, probably movie stars may fall into this category because they can get that drug, they have the money to buy it, they don't get in trouble with the law, so it's just like getting a cigarette in a way. But there is still some percentage of people who use these hard drugs, they still look normal. But definitely there is evidence for prefrontal cortex damage among these populations who abuse substances like heroin and cocaine. Now, in stark, and of course, there were a lot of other studies from functional neuroimaging, but also from structural imaging, looking at voxel-based morphometry, showing that there are severe abnormalities in the prefrontal cortex of polysubstance addicted individuals. Now, in stark contrast, when we consider the addictions to the so-called low-risk perception substances or activities, like smoking, internet addiction, gambling, or marijuana, then there is no obvious prefrontal cortex dysfunctions. You may find some if you really look very, very hard, but really most of the abnormalities are subcortical. They either involve the so-called impulsive system, mostly the striatum, ventral striatum, or the amygdala, or the insular system. But they don't usually involve the prefrontal cortex. So this is a sample of these studies. So here's a study we did in marijuana. So we looked at what brain abnormalities we may reveal in marijuana users. And as we find, most of the changes, most of the abnormalities are in the striatum. So there are some in the caudate, there's some in the putamen, maybe a little bit in the ventral striatum. But there is nothing at the level of the prefrontal cortex. There is no abnormality at the level of the prefrontal cortex. They're all subcortical. If we look at smoking addiction, here is not functional neuroimaging, but lesion studies. And I mentioned to you, because this is how we describe the insula system. If we look at what brain region is necessary for maintaining smoking addiction, it turns out to be the insula, not the prefrontal cortex. And this is really based on a study where we, as I mentioned before, we had patients who were addicted to smoking. They smoked 2-3 packs of cigarettes every day. And then all of a sudden, they had a stroke, and then the next day, they just stopped smoking. And even when you ask them, well, how come you're not smoking? They would say, well, my body forgot the urge to smoke. So pretty much the whole urge and the whole craving to smoke just went out completely. And when you look specifically at what is the cause of that, what is the link between this smoking cessation and the brain damage, and it turned out to be that the key neural structure is actually the insula. But not only the insula, actually we found later on it's the striatum is also part of that. So basically when the insula is involved, that cessation of smoking is much more robust and much more sudden and much more maintained, that it stays on for years, stays on for a long time. But even striatal damage could also cause disruption of smoking addiction, but not to the same extent as when you include the insula. Now you say, what happened to the prefrontal cortex? Well, nothing. Well, basically, the patient just stays smoking, so they continue the smoking, but the prefrontal cortex is not implicated in these instances. The same thing with gambling. We did something similar to smoking. Here we go, because people, even normal people, have a tendency, what is called the gambling fallacy. That is, if you're gambling on a slot machine and you tend to lose a couple times, you would think the next time you are going to win. So you tend to gamble even more because you think your luck is going to change very soon. So these are considered as cognitive distortions. They're non-logical from a mathematical sense. You shouldn't do that. And that's why they call it the gambler's fallacy. And gamblers have even much more severe form of that distortion. So again, we looked at people who gambled and then they had strokes, and we looked at damage involving different parts of the brain, patients who have amygdala damage, ventromedial prefrontal cortex damage, and insula damage. And it turns out that only insula damage is the one that corrects this gambler's fallacy. That means it cures the problem of gambling addiction. And again, it suggests here that there is a link between the insula in this form of addiction and not necessarily the prefrontal cortex. Internet addiction. And nowadays, internet addiction, it's a field, it's almost like drug addiction. There are instruments that really measure the severity of withdrawal and the consequences that you suffer from using the internet and so on. So there are instruments that you could use to assess how severe the internet addiction is. And we did this study with Facebook addiction, people who use Facebook, and we could measure how addicted they are to Facebook. And when you look at the brain changes in functional neuroimaging, most of the changes is actually nice linear relationship between activity in the ventral striatum, and that's part of the dopamine system, and the severity of the addiction score on Facebook. But nothing in relation to the prefrontal cortex or any of those regions related to the frontal lobe. So what determines then if a drug is going to be a gateway drug that escalates into use of hard substances? And I would say that's a dysfunctional prefrontal cortex. And I mentioned that earlier. That is, most of us, we could become addicted to something, but we stay there. We don't necessarily get an impaired prefrontal cortex so that we start making impaired decision-making all across the board, and then we lose our jobs, and we sell the house, and we do all these disastrous things. But the question is, who are these people? Why some people then cross that line and they become severely addicted? And I mentioned that it's a dysfunctional prefrontal cortex, and there is a debate as to whether this dysfunction precedes substance use or it is the consequence of substance use. And I like to argue that it actually precedes drug use. Now, there is no question that after somebody starts using drugs a lot, so the extreme use, the high doses of drug that are used later on could exacerbate the neurotoxicity and could increase the damage in the prefrontal cortex. But at least initially, the reason somebody allowed themselves to cross from one line to the other and go down that spiral of getting into more and more drugs, that's because of a prefrontal cortex dysfunction that precedes drug use. And the origin of that impairment can be genetic, and I'm not going to go over the genetic studies related to that, but there are a lot of genes have been linked to these behaviors, but also even the levels of dopamine and serotonin are determined by genetic factors. So all of those could have some genetic link that really render the prefrontal cortex working at some suboptimal level. But also there are environmental factors. And I think most of you know that we believe, or there's a consensus, that the prefrontal cortex, it's a brain region that doesn't mature immediately. So it takes at least 20 years, maybe 22 years to mature fully. So during that period of development, that is from birth until teenage years, until young adulthood, that brain region is susceptible, is vulnerable to environmental insults. What could be those environmental insults? We know, at least from animal studies, that if a young rat, if a puppy rat was separated from the mother, then there are massive changes in the anatomy of the prefrontal and the striatal system neural circuitry. So there are severe changes in the prefrontal cortex because of stress that is introduced in early childhood. So it's possible in humans. I'm here now speculating because I don't have the empirical data for it, but it's something that could be tested, that early child abuse, early separation of children from their parents could cause alterations in the development of the prefrontal cortex, and that could then serve as an underlying predisposition for using drugs later on. And perhaps also early drug use. While I was saying that drugs in general takes high doses to cause neurotoxicity, so it's not easy to just take drugs, to use drugs and cause brain cell damage. You have to really use very high doses. This may not be true if somebody who's 8 years old or 9 years old or 10 years old started using drugs, because the prefrontal cortex is still developing. It's like a fetus. This is why we tell pregnant women don't take drugs, because the fetus is much more vulnerable to the effects of these drugs during development. So it's quite possible that early drug use could cause alterations in the development of that neural circuitry. So these are a few potential environmental factors that really could alter the development of the prefrontal cortex, and then this in turn serves as a predisposition or as a way that render individuals vulnerable to becoming addicted to drugs later on. So to conclude, a relatively small sector of the population includes individuals who are more vulnerable or predisposed to poor decision-making due to a dysfunction in their reflective system or their prefrontal cortex. These individuals are more likely to start with the readily available substances which are perceived as low-risk substances like marijuana or cigarettes or alcohol. However, the lack of foresight and the poor decision-making and poor impulse control increases their chances of trying other substances. So to say it differently, their prefrontal cortex is not there to stop them. So the impaired decision-making in these individuals is non-domain specific. So they're impaired in every decision-making of life. And this is characterized by failure to learn from repeated mistakes. In contrast, most individuals have a normal prefrontal cortex, thankfully. They may experiment with substances or engage in other rewarding activities because they are perceived as low risk. However, their normal prefrontal cortex stops them from crossing over to hard drugs and spiraling out of control in using substances and going on to heroin and cocaine. So to say it differently, their prefrontal cortex is there to stop them. And that's why most of us could experiment with drugs, could drink alcohol, could do everything, but we stop at some point. So the impaired decision-making in these individuals is domain-specific, whereas their decision-making in other domains, like their work and everything else, remain intact. I think that was my last slide, and thank you very much for listening.
Thank you very much, Antoine.